Hello info person, this is Anton and welcome back to the channel. Today we're going to be discussing some of the more exciting discoveries in regards to the concept we sometimes refer to as exomoons. Moons orbiting different exoplanets that technically should be all over the place, but that even today we still have trouble discovering. And the reason we're talking about this today is because some of the recent studies have also suggested that when it comes to possibly finding life, specifically finding life beyond Earth, even though we normally focus on various planets orbiting stars in what's known as the habitable zone, at least when it comes to our own solar system, some of the most promising places except for planet Earth may actually be not planets at all, but various ice moons like Titan and Enceladus that many scientists today believe possibly contain something inside. And since our solar system contains over 400 confirmed moons, it stands to reason that exomoons should be also all over the place, orbiting most of the exoplanets and vastly outnumbering planets themselves. But after decades of searching, we have yet to confirm the existence of even a single exomoon. And so in this video we're going to discuss why this is so, why it's been so difficult to confirm these objects, but more importantly, we're going to dive into some of the more fascinating discoveries that are redefining our understanding of how and where moons form, and of course where they might host life. But I guess let's start with the challenges first. Why can we not find them? And the challenge here is quite simple. The signal from these exomoons is just incredibly faint. Currently, the most promising technique, which is what you see right here, referred to as the transit method, where scientists basically measure a small dip in starlight as the planet passes in front of the star, is just incredibly difficult to use for finding exomoons. And that's because a moon would cause an extremely tiny secondary dip, or what's known as a subtransit, that technically can also be caused by, for example, stellar activity or some other noise. And because of this difficulty, there's been a lot of controversy over a few candidates proposed previously. We've actually discussed both of them in some of the videos in the description, but here planets Kepler 1625b and Kepler 1708b resulted in a lot of debates. And though some researchers were pretty confident that these dips are caused by a moon, additional analysis suggested that this was just noise or even stellar variation, and there were no moons present. And so even today this is still controversial and has not been officially confirmed by anyone. These are still viable candidates, but we currently don't know what's happening around these two planets. But there have been at least one other method that potentially did result in something. Instead of using transits, scientists have also looked at gas clouds produced by hypervolcanic surface activity, kind of similar to what happens on Jupiter's Io, but even more extreme. And so here, heated by immense gravitational forces from the parent the moon is orbiting, the moon would produce constant eruptions that would spew a lot of material, forming a large torus around the planet and around the entire planetary system, and very likely extending closer to the star. And so here, by observing some of the emissions as the planet passed in front of the star, scientists were able to distinguish certain materials that seem to have been formed by some kind of a moon and not the planet. And so here at least one potential volcanic moon has now been discovered, but once again this is not confirmed yet. And well, technically we even have two strong candidates, WASP-39b and WASP-49ab. Both of these seem to show episodic signals of elemental sulfur dioxide, and even things like sodium and potassium, that is kind of similar to what we see coming from Io. This basically hints at very strong external solid body source, such as some kind of a volcanic moon. And that's because in this case the planet is a gas giant, so it should not have these specific elements in its upper atmosphere. But without confirming the velocity of this gas, and confirming that this is something in orbit around the planet, it would be difficult to tell for sure. And interestingly, in just the last few months, we also physically have seen a formation of the moon, or what seems to be a formation of the moon, coming from the James Webb Space Telescope. Although to be more exact, these were the observations from a planetary disk that's being formed right now, and specifically a circumplanetary disk, where a planet starts to form moons as well. So this is just gas and dust. And so here at least one massive planet, referred to as CT Cameloontis b, orbiting a star 620 light-years away from us, possibly showed us some signs of chemical and physical properties we expect from a potential moon-forming disk. So these are not moons yet, but may become moons in the future. And specifically here we had a lot of carbon-rich ingredients. Researchers detected 7 distinct carbon species including acetylene and benzene, with a lot of these carbon molecules being very different from the disk surrounding the host star. The disk itself is actually enriched in oxygen, and this difference does suggest some kind of a very rapid divergent chemical evolution This seems to happen super fast in many of these systems, and very likely happened in the solar system as well. And once again, these are not actual moons, this is just ingredients that are going to be building moons. This of course still confirms that the formation of moons seems to be a universal phenomenon, and moons, just like planets, seem to exist everywhere. But this particular observation also tells us a little bit more about differences in these moons. Here, these moons are going to be dramatically different from the water-dominated moons in the solar system, which is actually what most of our models are based on. And so here we seem to see formation of carbon-based moons. But exactly what this is going to produce is of course unknown. But surprisingly, one of the best and one of the more unusual locations to try to find these exomoons, and possibly even find locations somewhat hospitable for potential life, is not around a typical star system, but instead maybe around what we refer to as a rogue planet. A planet that becomes its own system because for one reason or another it does not have a parent star. And we recently discussed some of the major discoveries about rogue planets in one of the videos in the description, but today we're mostly going to focus on moons that seem to form around these objects. And so based on a lot of simulations, we know that many different giant stars very likely kick out quite a few planets as they evolve over the years. And so many estimates today suggest that there are probably 10 times as many rogue planets out there as there are actual stars in the galaxy. So something like 1 to maybe even 4 trillion rogue planets in the Milky Way. Additionally, various simulations based on Type 2 supernova involving large stars suggest that many of these planets usually get completely ejected from these systems, but surprisingly with their moons. Although in this case, the explosion itself and the dramatic expulsion usually results in the moon acquiring a slightly different orbit, very likely eccentric or elliptical. And while one of the recent studies you can find in the description explores the idea referred to as habitability, a term describing minimal physical, chemical, and energetic requirements necessary for life to form somewhere out there. And that's because some of these moons orbiting these rogue planets potentially have everything we need, or that we expect life to need, to basically start somewhere out there. And the key here is what's known as tidal heating, with the best example once again being Io. As the moon travels along a certain path and as it interacts gravitationally with the planet or with objects around it, massive gravitational tug stretches and compresses the moon so much that it then generates immense amount of heat inside. And on Io, all of this heat results in volcanism. But on some other objects, it may also result in a lot of heat required to maintain liquid ocean. And by the way, both the moon and planet Earth also experience just a little bit of tidal heating from orbiting around one another. And well, according to these simulations from this recent study, anywhere from 12 to 15% of all of these rogue exomoons, or moons orbiting around rogue planets, possibly experience tidal heating comparable to the levels found on Europa and Enceladus. And if they orbit far enough away, this heating can also last for billions of years, basically exceeding the age of the solar system. Which means that on these worlds deprived of starlight, they can still actually contain habitable conditions inside the moon and have them for long enough to possibly even cause evolution of more complex life, assuming it can happen the same way it happened on Earth. Which of course also suggests that we are more likely to find life somewhere inside and not on the surface. This of course includes the moons in the solar system. And some of these revelations about rogue planets and their moons go even deeper. Based on this other study, on the free-floating planetary mass objects, also known as FFPMOs, which is another way of saying rogue planets that are really massive, usually between 5 and 10 times the mass of Jupiter, we know that some of them do not have to be ejected from anywhere, but can actually form alone, very similar to a typical small star. And so based on some of the recent James Webb observations, scientists actually confirmed that quite a few of these objects seem to harbor their own disks. Basically, they don't have moons yet, but the moons are definitely growing. And so here once again we have signs and evidence for actual raw materials for these moons to form, which will then potentially exist in this location for billions of years. Crucially though, researchers also detected silicate emission features, which is the first such detection of planetary mass objects around any rogue planet. Silicates are important because normally, in a solar system at least, they form rocky planets. And the characteristics for these silicates show clear evidence of dust growth and crystallization, which of course suggests that many of these large rogue planets have quite a lot of potential to form their own miniature planetary systems, or I guess technically exomoon systems, but scale down in mass dramatically compared to what we usually find around planets. And this directly supports the idea that formation of complex planetary systems with actual rocky moons and small planets is not exclusive to stars. And because so many more of these objects seem to exist out there, there's now a much higher chance to possibly discover something really exciting, in this case life of course, not around a typical star system, but possibly around one of these rogue planets, or FFPMOs. But at the moment, what we're seeing is of course just a forming disk, which will probably take millions of years to evolve. So this is definitely not a planetary system yet, or not a moon system yet, and I keep switching between these two terms because we don't even know what to call these yet. But one day they'll probably resemble something like this. Although at the same time, some of the other research also pointed out that there is maybe one location where we should probably not look for moons because they're extremely unlikely to exist. And ironically, it's the place where a lot of scientists have been trying to find life for the past decade. Turns out that the typical M-dwarf star, also known as a red dwarf, the most common type of a star in the entire galaxy, and the type of a star that we know seems to host most of the rocky planets in the entire galaxy, seem to not be a good place to find moons. And that's because usually these stars are very small, and the planets orbit very close to these stars, which would create a lot of instability for any possible moon. And so because of a lot of tidal forces from the star itself, and because of additional interaction with the planets nearby, most of these red dwarfs are extremely unlikely to contain large moons for more than 10 million years. And so right now scientists think that we're not going to find any moons around these objects, and they're mostly just going to contain planets, which are also extremely unlikely to be hospitable either, with many of these planets possibly similar in size and mass to planet Earth, which is of course what was discovered around the famous TRAPPIST-1 system. But at the moment we don't really know if these planets are hospitable because these are extremely different systems. And in at least one video recently, we did discuss some of the most recent discoveries from the TRAPPIST-1. Just in short, so far no life and no habitability. But nevertheless, the study of exomoons is still really important, because now we have moved on from mere speculation about these objects and the speculation about their existence and their chemical makeup, to now actually seeing at least some of them being developed, and studies that also suggest some of them do have a chance to have habitable conditions inside. And though we still lack a single confirmed detection of an exomoon, a lot of evidence we've discussed today is still very compelling. And it's really the exomoons right now that may be critical to host some kind of an extraterrestrial life somewhere out there that one day we might even find. But in order to confirm this, and in order to confirm that life can even exist there, we first have to confirm it here in the solar system. And that means investigating objects like Enceladus, Europa, and even Titan, and trying to see if life can actually form inside, specifically in the ocean underneath. But as technologies advance, and as we get more telescopes, such as the Giant Magellan Telescope and the Habitable Worlds Observatory, we may finally find new techniques to discover signs of life somewhere out there, possibly confirming it sometime in the future. For now though, we just have a bunch of propositions, different ideas and theories that suggest that life does have a high chance to exist inside some kind of an exomoon around a rogue planet, so basically in some very dark, very alien place. But finding evidence for this is going to be super challenging, which means that we'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.